Let's talk about sequences. Sequences are where you look for patterns, right? So here's a simple one. It's triangle, square, triangle, square, square, triangle, square, square, square. The next one would be triangle. What about the next shape, for example? Circle, triangle, square. Circle, circle, triangle, square. Circle, 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 triangle, square. Well, the next one would be circle. So now let's look at some numbers. We've got 0, 3, 6, 9, 12, 15. If you notice the pattern, we're adding 3 each time. So the next one will be 18. How about this one? 5, 3, 1. First thing you notice is that we're going down. 5, 3, 1, negative 1, negative 3, negative 5, negative 7. Well, let's look at the difference here. The difference here is 2. The difference here is 2. The difference here is 2. Do you see it? So we're subtracting 2 each time. So if that's the case, then the next number would be negative 9. What about this one? 1, 4, 9, 16, 25, 36. Hopefully, you've noticed that these are all squared. They're all squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. So this one must be 8 squared. So that would be 64. What about this one? 2, 4, 8, 16. Do you see it? To get to 2 and 4, you double. To get to 4 and 8, you double. To get to 8 and 16, you double. So that this must be doubled, which would be 32. You double each time. So here's the definition. A sequence is a list of numbers or other things, right, that change according to some pattern. With numbers, we usually assign each spot just some symbol. The first one, well, let's talk about this. Each one of these is called a term because it's a term in a sequence. Basically, it's a spot, all right? This is term 1, the first term. This is term 2, the second term. The third term, the fourth term, dot, 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 dot. And this one's called the nth term. It's some term far out at the end that we can assign an equation to. So for example, for the sequence of the squares, 1, 4, 9, 16, 25, 36, the first term, A1 is 1. The second, A2 is 4. The third, A3 is 9, and so forth. Well, what would the 10th term be? You know the pattern. The pattern is x squared, just square. So the 10th term would be 10 squared. Well, 10 squared would get you 100. If you know the pattern, right, you know the equation, then that's fine. Well, what about A17? That'd be the 17th term. Well, all I have to do is square it. So I get 289. So sometimes it's really easy to find the patterns, and then sometimes it's just not. So let's take a look at this one. For this one, you've got 1, negative 2, 4, negative 8, 16, negative 32. Okay, first of all, we notice that we are basically oscillating between positives and negatives, right? And if we ignore the negatives and just talk about the numbers, to get to 1 to 2 and 2 to 4, it looks like if I take 1 times 2, I get 2. If I take 2 times 2, I get 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2 would get me 64, but now I need to talk about those negatives, right? So instead of just multiplying by 2 each time, what happens if I multiplied by a negative 2? So for this one, if I multiplied by a negative 2, it would get me that negative. And here, if I multiplied again by a negative, it would get me that positive. Oh, this would get me that, right? That would get me the negative, and negative, negative, that would get me the positive. So we know that this next number is going to be a positive. All right? What about the 20th term? Okay, well, we've got, let's see, the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, the seventh term. Okay, yeah, I don't want to write this out. I don't want to write all these terms out. And you don't either. So what are we going to do? We need to come up with a formula, right, to help us. Because when we have a formula for the nth term, I can find things like the 20th term or the 100th term, and I don't have to write them out. All right, so before we get into formulas, there's two types of sequences. We have a finite sequence. This is, it stops, right? There's no going on. It stops, finite. And then there's infinite, right? Dot, dot, dot. It keeps going forever and ever. Okay. So we need to come up with some formulas. So remember, we had these terms, first term, second term, third term, nth term. The nth term is what we are going to write the formula on, because the n can be 1, it can be 2, it can be 15, 37. You can find any, right? Any of them, just if you have the equation for the nth term. All right, so how does this really work? Let's build the sequence together, and here is the nth term formula. This is the formula. A sub n equals 2 to the n minus 3n. Remember, what is n? N is just whatever they're going to tell you. Is it the first term? If the first term ends 1, second term then ends 2, third n is 3. So let's find the first term. I'm going to let n be 1. First term, a1. That's 2 to the first minus 3 times 1. Well, that gets me negative 1. Well, now I want the second term, a2. Just plug in n is 2. Everywhere. So 2 squared, right? 4 minus 6. You'll get negative 2. The third term, a3, right? And so on. You can keep doing this. And our sequence will keep going, because I didn't say this sequence goes to the 5th term or the 10th term or whatever. So when you're given a formula for a sub n, right, you stick in n equals 1, and then n equals 2, and then 3, and then 4, and then 5. That's to get the first 5 terms. And why am I telling you that? Because some of your problems are going to say, what are the first 5 terms of this sequence, right? Like this one. Build the sequence. The first 5 terms, whose nth term, or equation, right, is given by this equation. Well, I want a1. Well, if I want a1, you're going to let n be 1. So I'm going to plug it in here and here. So a1 is 6 times 1 minus 4. 2. Now I want the second term. Let n be 2. So 6 times 2 minus 4. 8. Now let's find the third term. 6 times 3 minus 4, 14. Now I want the fourth term. So it's real nice and easy. It's just basically plug and chug. You're just plugging these things in. Now I want the 5th term. And as long as you know how the formula works and where to plug the number in, just plug them in the ends, you're good to go. So it says the cool thing about the last 2 formulas is that you can just jump to find any single term in the sequence. And why is that? Because I have an nth term equation. So for this one, this equation we were just looking for, if I said, hey, go find the 100th term, you totally could. You would plug in n is 100, and bam, you've got it. Not bad. Sometimes, however, formulas build off the formula before, let me start again. Sometimes formulas build off the term before. So sometimes the nth equation builds off the term before it, okay? So let's take a look, and these are called recursion formulas. Notice that I have the nth equation, yes, but there's this funny little n minus 1. Remember, n minus 1 is the term before. Let's go back. Remember? Where did we have it? I talked about it somewhere. Oh, hogwash. Where did I put it? Anyways. I have no idea where I put it. Anyways, so the one before it, right? If this is the third term, 3 minus 1 would be the one before it. That's 2, right? It's the one before it. I can't find what I was looking for. Anyways, that's fine. So these are called recursion formulas. They build off the term before, and they will give you that term. So, for example, they're not bad at all, I promise. We know that the first term, A1, is 2. I know the first term. Let's go find the second. I want to find the second term, so n is 2. I need to find, this is the 2 minus 1, right? 2 minus 1 is what? A1. Oh, that's lovely. Because I know that because they told it to me, right? So I know that this is A1, and I know A1 is 2. So I'll just plug that in. Negative 3 times 2 plus 5 is getting me negative 1. Oh, now I want the next term. Well, the next term is the third term. The third term. Again, I have to find the term before, right? Negative 3a sub n minus 1. That's 3 minus 1. That's the second term. So when you're working with recursion formulas, you got to be really careful, because if you mess up on one term, the rest of them will follow, because you're using the term before. So negative 3, a2, a sub 2 plus 5. So negative, I know what that is. I know what the second term was. So I'm gonna plug it in. And it's the same thing here. This is the fourth term. I'm going to use the term before. I know what that is. I plug it in. Same thing here. So these are called recursion formulas. And generally they want you to get the first 5 terms. But you use the term before, and that's why they have that n minus 1 equation in them. Let's take a look here. Okay, I've got a recursion formula here. Now, notice, not only does it have the one before, it also has the one before the one before. What? That's why they have to give you 2 terms. If I know A1 and I know A2, I should probably start at A3. I should probably start at A3. So that means n is 3. Okay. If n is 3, I'm going to have I'm going to have 7 a 3 minus 1 minus 2 a 3 minus 2. All we're doing is plugging in what I want to find. I want to find the third term. N is 3. So what is a 3 minus 1? What's 3 minus 1? It's 2, right? So this is 7a2 minus, and what is a 3 minus 2? Well, what's 3 minus 2? Well, it's 1. Oh, that's why they gave me the first term and the second term, because I need them. So I have 7 times a2 is 3 minus 2 times a1 is 1. So that'll get you 19. Now we can go to the fourth term. With the fourth term, n is 4. So it's 7a 4 minus 1 minus 2a 4 minus 2. Okay. 4 minus 1 is 3. So this is the third term. And 4 minus 2 is 2. This is the second term. So that means I need 7 a3 minus 2 times a2. Okay. So that's 7 times. What did I get a3 to be again? Oh, yeah, 19. Minus 2 times a2 they told me. That's a 3. All right. What is that, 127? And the fifth term, like I said, 5 terms usually does it. A is a 5, n is 5. So 7a 5 minus 1 minus 2 times a 5 minus 2. All right, 5 minus 1 would be a 4, and 5 minus 2 would be a 3. So I've got 7 times a 4 minus 2 times a 3. Oh, there we go, sorry. Oh, A4. I found A4, the one before, right? So 7 times 127 minus 2 times A3. We found that one. It was 19. So 851. You can do sequences on your calculators, and these help a lot. So basically, you're going to follow these steps. Go to second stat. You go to basically it's the list option, the list menu. You're going to arrow over to OPS, scroll down to SEQ. SEQ is sequences, and you're going to press enter. Now it wants a couple of things, and it wants it in this order. It wants the formula, it wants the variable, it wants the starting value for n,